Hello everyone, welcome to our video today about position. So really, what is position? We've heard that word before. It's definitely one that we're familiar with. You might say like, oh, I'm in a sitting position or standing position, but that's not what we're actually talking about. We're talking about position in physics, which is talking about a location. And the location also is something that we can actually measure, which is something a little bit different. So, we're going to define position as the distance an object or person is from a reference point. And now the question is, what is a reference point? So a reference point can be anything that you want it to be. A reference point is basically a spot that we designate or we call zero when we're talking about position. So, for instance, right now I'm sitting at a desk. My desk could be 0, and I could, get up, walk to the other side of the room, and measure my distance from that desk. It could be from your bed, right? That's where we start each day. Then your position would be how far you are from there. Your position could be your desk, could be your locker. It really could be anything that you want. When we were doing the sensors were 0 in our reference point, okay? The easiest way to think about position is as a timeline, or not a timeline, but a number line. So we take our reference point, we make that 0, and here we go. This can be measured in anything that is a unit of distance. We could do meters, could do feet, inches, miles, kilometers, any of those things, but the thing we'll use the most is meters. We'll just mark off some things here. So we'll go 1, 2, 3, 4. These are all meters. So, if somebody was standing right here, then their position would be 0. If they went and they walked, now their position is right here. We would say their position is 1 meter. Could walk this way. Position is now 3 meters. Walk backwards. Now we're at 2 meters. I think you get the gist. So it's basically the distance between your reference point, which is this, which could be anything that you choose, and where you actually are standing. Now, can your position be negative? The answer is yes. Let me show you why. Sounds a little crazy, right? If we say our position is 3 here, talking about 3 meters, what if we went this way instead? Okay. Alright. So let's say, for instance, we had somebody standing here, and we had somebody standing here. If we didn't have the negative here, so let's hide that for just a second, we would say this person's position is 2, and this person's position is 2, but they're clearly not standing in the same spot, right? So that's why we say this person's position is 2, and this person's position is negative 2. It would not make any sense if we said they're both 2, but they're not in the same place. You can't have 2 things in the same place, but not in the same place. Hopefully that makes a little bit of sense. So basically we would say, if this was our sensor from today, draw a little sensor there, and your thing is going this way, it senses this way, it says, alright, you're at 2. It can't actually sense behind it, but you could go behind it, and that's when you would say that your position is actually negative. So we'll be talking about position quite a bit more. We'll get some more practice with it. So if you haven't totally wrapped your head around it, that's totally okay. It's maybe a little bit not what you thought it was, but, once you start to think of it just on the timeline scale, we're not going to really go any more complex with position than just a timeline. Gets a little bit easier to wrap your head around. So if you think in position, think timeline. Remember your reference points. Before you can determine a position, you have to have a reference point. You can't say your position is 3 and not have a 0. You always have to pick your 0, then you can measure your position. All right, everyone. Have a good night.